You must have seen a similar picture like this, where a stronger piece or stronger slab of rock is surrounded by slightly smaller fragments of it. These look so much exact, but they are different, and it must have led to your amazement what has caused this huge, otherwise strong piece of rock to be scattered into small pieces like this over here. Let me tell you, it is due to the elements of weather that are acting on the piece of or the slab of rock that this is divided into smaller fragments, and due to the elements of weather involved like the wind, temperature, heat and water, it is known as weathering. In this video you will have a general idea about what weathering is, and this will be brought to you by me, Pratik, and without any further ado, let's head right into this. What is weathering? It can be defined as mechanical disintegration or chemical decomposition of rocks through actions of various elements of weather and climate. The basic word here is disintegration, which means breaking of a larger piece of rock into smaller ones. And it could be physical disintegration or mechanical decomposition. Then weathering occurs on site. That means element of transport is not at all involved, and that is what is sets it apart from erosion, in which element of transportation is involved. All right, and this weathering could be divided into physical and chemical weathering, referring to the forces that are acting on the rock. Now, for you to understand what physical and chemical weathering, you should understand what physical and chemical changes are basically. Let's try to understand it with an example. Here we have milk. When you squeeze even few drops of lemon into milk, what happens? You will have an entirely different material, which with particular process could be brought up to this, which is paneer or cheese. Since it's a chemical process, you can see the milk is made into an entirely different material, which has almost entirely different properties. It was a liquid prior to this, now it's a solid, as you can see. But can you make milk out of paneer? No. So this change is irreversible. It can't be reversed. That is chemical change. Now what is physical change? This paneer is brought down to smaller pieces of or chunks of paneer, and these have exactly similar properties, unlike over here. All right, so these have similar chemical properties, and these have in chemical changes the chemical properties are entirely different. All right, so these are certain points about physical weathering which we need to know. It is a result of applied forces, gravitational forces, exponential forces and water pressures could serve as these applied forces. We'll see about it in slides to come. Now the first force which we are going to discuss is gravitational force, and due to the gravitational force there could be loading and unloading. When you unload a rock, there is a vertical pressure release, and since there are vertical pressure release, the upper layers of rock they expand, and it causes into development of fractures which are roughly parallel to the curved ground surface, and it results into exfoliated slabs. Then they are smoothed out and rounded out to form exfoliation domes. Let's try to understand with an example. Let's say we have a spring, and on the spring a guy like Big Show sits. What happens? The spring contracts, and the kinetic energy of the spring is brought down to potential energy. But what happens if this guy just steps down, and the potential energy of the spring is converted to kinetic energy, which causes it to expand, and there is vertical pressure release. All right, there is vertical pressure release. This similar action could be seen in case of rock. Let's see. For example, this rock had its surface somewhere over here a few years ago. When due to elements of weather this eroded, the load over this rock is down because the surface, the overburden pressure or the burden over the rock was released in the similar fashion over here. So the rock reacts like a spring, and there is vertical pressure release, and these layers like the coils of spring, they separate out a bit to an extent where these could just drop here and there is formation of a structure called exfoliation dome, which is smooth and round. Here is how the changes take place. There was a overlying material over here. This got eroded due to the elements of weather, and this caused flaking of the rock layers or the rock surface, and this results into formation of exfoliated dome. The basic idea, the important thing here is the load is removed and the rock, it expands vertically because there is vertical pressure release. All right. Now this takes us to the another change, that is temperature. Another cause of weathering is temperature, and this is very important. The temperature, it's always varying. It rises at some point of time and it lowers at some point of time. It could be seasonal or diurnal, meaning daily. It could be different in the day. It is different in the day and it is different at the night. So this temperature change causes expansion and contraction of the rock materials, and this results into subsequent exfoliation, and these are known as stores. So we'll see it with an example. Suppose there's winter and the temperature of the surrounding is quite cold. What happens? These organisms, due to the cold, they just push against each other, and this as a group contracts due to the low temperature. And when the temperature eases out a bit, these guys just move around, and since the temperature is more, they want more air to circulate between their bodies so that they could keep their bodies colder. So you can see how these organisms react to different temperatures. Similarly, when a rock is heated, it expands, and when it is cooled, it contracts. And due to this, the joints and the cracks in the rock, they are under great pressure, and this causes the rock to break into pieces, and this is how you can see the broken pieces are scattered around here and there. And this, when in case of granite, it is known as TORS. All right, TORS, TORS. Then we have freezing and thawing. We know freezing is directly related to temperature change, and we already have seen what temperature does to a rock, and it is effective at high elevation in mid latitude, where freezing and melting is often repeated, and it causes sudden expansion and high pressure, which affects again the joints and cracks. Let's see how. First of all, water collects into the rock crack. When freezing temperature is reached, water freezes and expands, and forcing the crack to widen. Unlike any other material, water when freezed, it expands. All right, and ice thaws, making the cracks bigger, and this repeated expansion and contraction causes further cracks till the rock splits into two. All right, two or even more. Then there is salt weathering. Rocks have different material into them. They have different salts. Just as different materials expand and contract, the salts also respond to temperature changes, and when high temperature is reached between 30 to 50 degrees Celsius favors such salt expansions, and salt crystallization is the most effective of all salt weathering process. Similarly, a structure like this could be formed. It causes the expansion of salt. This causes the rock to expand and contract, and it causes variance in pressure and force release, and that is why a structure like this could be formed. And thank you for joining me. In the next video, we'll discuss some new topic which would be exciting, and thank you for your cooperation.